Hi, my name's Mike and welcome to my first tutorial where we're going to create a project for writing our own game on the iPhone. I've been writing apps now for a few months on the iPhone and having lots of fun doing that, and I decided that I wanted to give it a go and write a game on the iPhone. So I've had a look around and I've decided that after looking at examples like Crash Landing that Apple provide and you can download, that I will use OpenGL and have a go at creating my own simple game. It's going to be simple because I'm learning OpenGL as I go. It's not something I've used before. So for that reason, I'm going to stick to a 2D game, two-dimensional game, rather than worrying about 3D at the moment. Maybe that's something I'll tackle later on, but for the moment, as I learn, I'm going to stick to 2D. So I'm going to have don't know how many tutorials yet it's going to take, but I'm going to, as I learn and actually make some progress myself, I'm going to share my experience and what I've learned through these tutorials. These are the first screencasts that I've done, so if I make any mistakes, I apologise. Hopefully I'll get better and slicker at these as I go along. But as I said a little while ago, the key item that we're going to cover in this tutorial is to create our project. So create a project in which we can start to draw things to the screen, and we can then use that as a framework to build our game. So by the end of this tutorial, we'll have a project and we'll actually be printing a sprite onto the screen or a graphic onto the screen, and we'll then stop there and we'll then move on in the next tutorial to look at some of the other technologies and some of the other things that we need to worry about. So sprite sheets, being able to move sprites around, collision detection, and all the things that I think I'm obviously going to have to deal with as I go through and I start writing this game. So one of the things that you'll need to have at your side, if you like, is a copy of the Crash Landing example that Apple provide. So in my folder here, I've got Crash Landing downloaded, and the reason is there are a couple of great classes in here that I will be using as part of setting up our project that just deal with some of the complexities of getting images from your image.png files into a texture, which is what you use when you're working with OpenGL. So we'll be grabbing those from in here, so it's handy having that available. I've also got a graphics folder here, which I've got my little player PNG file in. So this is going to be the graphic that we're going to have we're going to use and display on the screen by the end of this tutorial. So let's get started, and what I'm going to do is I'm going to, inside Xcode, create a brand new project. So my new project is going to be an OpenGL ES application. And this is handy because it gives us a lot of the wiring already done for being able to get a view up in the iPhone, be able to render to it as well using OpenGL. So I'm not going to go through too much of the detail in this. I'm still working out some of it myself, but it gives us a good framework to start to build from. So I'll select that and I'm going to give it a name, which is going to be Tutorial 1. So this gives us our standard project. And in here we can see that there's a few things that have been created for us already, as is usual in Xcode, and we're using templates. There's a delegate that has been created and been given the same name as our application. And there's also a view which has been created, and this view is what has been wired up to our main window and is actually going to be what we write to. So if we have a look under the resources folder, we can see there's a main window.nib, and that's already got the wiring necessary to point the view that it has to this particular class that we have here. We can also see that there are some frameworks that have been loaded as well. So OpenGL ES is obviously one we're going to be using, and Quartz Core is in there as well. So we've really got the foundations that we need now, but obviously we need to have a look and see what's in there that we can keep and what is in there that we don't need. Now, at this point, the actual application works already. So if I select Simulator, because we want to run it on the simulator, and I run the application, we will see that when it comes up, it actually already does something, which is to rotate this colored cube in the middle of the screen. So the app is actually pretty much there in terms of writing things to the screen and animating them. But obviously we want to do our own thing inside here, which is have our game. So there's going to be some code that we need to remove and replace with our own. So I'll stop that and we can start to have a look at some of the code that we actually need to worry about and we actually need to change. Now, inside the delegate, there really isn't anything for us to change. All this is doing is within our GL view, and GL view is basically an instance of our EAGL view, we are setting the animation interval, which is a property that has been defined for us, and we're setting it to this 1 divided by 60, and this is giving us basically 60 frames per second. And that's how many times we are going to be redrawing our scene, if you like, on screen, is 60 times every 1 second. And that should give us a really nice, smooth animation with no glitching and no sort of jumps between one part of the screen and the other. Or the other thing it does within the application did finish loading method is it just runs this method called start animation. And as we go and have a look inside EAGL view, we'll see what start animation does. But for the moment, there's nothing to change in here. We just leave the delegate as it is, as all of our changes are going to be done in the EAGL view. So if we go inside the EAGL view, we can see here that there are a number of classes already created for us. We have the initWithCoder, which gets called when this particular view is created. Because it's being created from within inside a nib file, then initWithCoder is the method that is called within our class. And in here, it just does some configuration work for us. So it just sets up the GL layer, which has been created and what we're going to write to. It sets that up with a number of parameters. If you go and look this up in the documentation, it tells you all about what these parameters are and what they do. But for our needs, we can just leave them exactly as they've been put in for us inside the template, and we can just move on to looking at other aspects of this. Again, inside our initWithCoder, we are setting the animation level, so we're giving it a default setting in case it isn't set elsewhere, which is just good practice. And it's also in here where later on we're going to have more of our initialization code, so the code that we are going to use to set up OpenGL, for example. So in here we will have our OpenGL init code. Okay, I'm not going to put that in just yet, we'll put that in just a while. If we carry on moving down, we'll see that we've got a draw view method. Now, this is where all of the drawing action goes on, as the name would imply. So inside draw view, we are actually drawing things to the screen. And at the moment, this may all look a little bit confusing, but this OpenGL that we can see in here is actually drawing that colored box and causing it to rotate. Okay, now a lot of this, therefore, we don't need. We want to actually create our own information in here, sorry, our own graphics in here for our game. So there are some things in here we need to delete. We can delete these two arrays at the top because they are just defining the dimensions of that box that we're seeing spinning around, and it's also defining the colors in the box as well, and that's why we're getting that colored box being drawn on the screen. So we can delete that, we don't need that. We want to keep the next three commands because these commands are defining the frame buffers for us. So there's a render buffer and there's a frame buffer, and the frame buffer is almost like an off-the-screen area that has the same dimensions as the screen, or is configured to have the same dimensions as the screen. And when you write anything, or you draw anything, sorry, that's where you write it to. You write it to that frame buffer, not directly to the screen itself. When you finish then drawing everything to that frame buffer, you swap that frame buffer onto the screen. Okay, and then what's on the screen you swap into the frame buffer. So now you can see on the screen what has just been drawn in the background. And then while that's being displayed, you draw in the background again the next version of the scene and you swap them again. And you just keep swapping these scenes over. And it really is just so that you're not trying to read from the screen memory as it's trying to draw on screen, as well as you're trying to write to the screen memory. If you try and do that, you can have some timing issues and you can get some tearing and some artifacts on the screen. It just doesn't look very good. So it's good practice to have, you know, flicker-free animation and flicker-free updates if you're looking at one view and you're updating the other and you switch them. So this here, what we're doing is we're saying that the buffer we're going to bind to, in other words, the buffer we're about to write to, is the frame buffer. Okay, and we can see here we've got this thing called the view frame buffer, which is set up in another method inside our class. GL viewport, this is setting up the viewport that we're going to be looking at for GL. So 0, 0 is the bottom left hand corner of the view, and then we have the backing width and the backing height, and they are both defined when you're creating your context and your view buffers. They are created at that point. The next piece of code that we have here around matrix projection, model views and that kind of thing, we're going to see those things again in a moment when we actually set our OpenGL parameters. For now, we don't really want any of this stuff in here. So from the GL draw arrays all the way up to that first matrix mode, we want to delete. So we get rid of that. The next thing we want to keep are the last two lines in here. So if you can imagine, up here, we've gone and bound our frame buffer to be writing to this background frame, not to the screen. We then draw our game scene. So in here we draw game scene. And then the next thing we have to do is we have to take what we've just drawn in that frame buffer and stick it onto the screen. And that's what the next two lines of code are doing. We first of all bind to the render buffer what the view render buffer is, and we then present that onto the screen. Okay, so we actually are showing to the screen what's been taken or drawn in the frame buffer and is now going to be on the render buffer. Okay, so that's what we're doing here, we're swapping those over. And that's really it. So that's obviously where we're going to have a majority of our drawing code is going to go in there. But for the moment, we don't have to worry about anything else on that. The next set of arrays are really things that we don't have to touch with. These are methods that have been created by the template, and they do what their name implies, really. They create a frame buffer, which using OpenGL and things like generate frame buffers and generate render buffers, because you can have multiple of these if you need to. We're actually creating the buffers necessary, the areas of memory necessary to actually have what we're going to draw on screen and what we're going to be drawing in our frame buffer in the background. So we have a create, we also have a destroy as well, so we can get rid of them if we need to. And the next method that we see is the method that we saw being called from within inside our delegate, which is this start animation method. And in here what it does is it basically just kicks off a timer. A standard timer, which is repeated, which is why we have yes at the end of repeat here. The target of the method that is going to be run, or the target for the actual timer itself, is self, so it's this class that's going to be called. And we can see here that every time this timer triggers, it's going to run the draw view method, or call the draw view method, which we've just been looking at a up above. Okay, so that's all that happens, is it kicks off a timer that 60 times a second is going to call draw view. So pretty straightforward. The next set of methods just really deal with stopping the animation and setting the animation timer and setting the animation interval as well, so that we can actually see what is going on, so that we can actually define how many times a second the timer should actually be run and what it should be doing. And then lastly, we have the normal deallocation routines that are standard. Okay, so we've gone through some of the standard methods there that are inside our EAGL view class, and we can now start adding some of the code that we need to actually get this project to a point where we can start writing our game. So what we'll do is we'll go back up to the top here, and you'll remember that we put in this little comment earlier, OpenGL init code. So this is where we want to put in some of our code now, which is going to configure OpenGL for us to use as part of our game. So I've already got some of this code that I'm just going to paste in here, like so. I'm not going to go through today what this code is doing. What we'll do is we'll cover this off in some other tutorials when we actually start using some of this stuff. But it's really just making sure we are setting up the screen dimensions, setting up how things are going to be drawn to the screen, so the kind of blend functions we can use, which later on we'll do and handle things like transparency and so on. We're also setting up the fact we want to use textures, and textures are the term given to images that you want to actually display on the screen. We're also doing things like disabling depth, because we don't need depth in 2D games. We only are looking on the X and the Y plane, not the Z plane, which is in and out of the screen. And we're then, last of all, something which we will play with a little bit today is we are setting the clear color at the bottom here. And what the clear color does is, maybe as the name actually says, whenever you clear the screen, the GL screen, you can define the color you want to be used to actually clear the screen with. And at the moment, we're defining it as black. You'll see as we go through that OpenGL, for a lot of these things, normally accepts value ranges of 0 to 1, and they're floats. And it does speed things up for GL. So 0 is completely black for all of them, red, green and blue, and 1 would be full intensity. The last option here is alpha. So you'll see when we start playing with colors later on that you can define the red, the green, the blue, and the alpha. So you've got lots of opportunity to configure things as you want to. So from our point of view, that's pretty much all we need to do now for actually configuring the screen and actually setting up the OpenGL stuff. And as I say, we'll cover that in more detail later. Now we're going to move on and look at the main game loop that we need to create. So at the moment we are 60 times a second calling our little timer, and that is calling the method that we've got over here, which is the draw view method. Okay, now that's fine, but having everything crammed in here, so having all of your game logic as well as the drawing of your game entities all in one method can get a little bit complicated. It is how they've done it inside Crash Landing. They've got both game logic and rendering inside there together, but it is a fairly simple game, so it's not that bad having it in one method. What I want to try and do is, having done some reading on this, is use the best practice out there, or what seems to be the best practice out there, which is splitting up drawing to the screen from the logic of the game. So in other words, we have a method which will be responsible for moving our enemies and our good guys and bullets and things like that, and we'll have another method which is then responsible for drawing them to the screen, which will be this one. So tying those two things together, we need to create a main game loop. So we need to create another method which will actually be the method called by the timer, and it'll be this method that will then be responsible for going and making sure the logic is updated for the game, and then going and making sure that the graphics are drawn for the game. So what we'll do it right above the draw view that we have here. We will create a brand new method, and we're going to call this main game loop. Okay, something very simple. And in here there's going to be a few items that we need. Now at the moment we have a timer which is kicked off 60 times a second. But if you look in the documentation, it's its best efforts basically. It will try and run as often as it possibly can to meet that time frame. But it might be a little bit late sometimes, and it might be a little bit early sometimes. So if we let that happen, we may actually start to see some jagged movement in our game. We might see things skip slightly as they are updated late. So instead of it being 60 frames a second, we suddenly see the frame rate drop. And one of the ways of tackling that is every time we run through our main game loop, we have a look and we see how much time has passed since we last ran through the game loop. And we use that, and we call that the delta. And we use that when we're calculating the movement of anything, so that if we were sort of calculating it in milliseconds, we can then in our game decide that character A is going to move at however many pixels per or fractions of a pixel per millisecond. And it means that by using delta, if the timer isn't quite accurate, delta makes up for that, so we always get an accurate, consistent speed across the screen, even if the timer isn't giving us the accuracy that we're after. So that sounds probably more complicated than it is. What we're going to do is we're actually going to create just a couple of variables that will keep track of that particular time that we're after. So I'm going to use CF time interval types here, which is what they were using inside Crash Landing, and I'm going to call it time. And if you look at this code, you'll recognize it as code that does come from Crash Landing and that they were using themselves. I then need to have a float because I need to actually store the delta that we calculate. I have time, so I now need to set the time. So I'm going to set time, and I'm going to set it using CF absolute time get current, so we can get the current time. And then we calculate the delta. So delta equals time minus and something called last time. Now we haven't created anything called last time in a minute, so we'll need to go and do that in a second. But we'll finish off and say that when we get to that point, we then say that last time equals time, because obviously when we run through next time, we want to know the difference between now and then. So I'll just close off that method. And what we need to do is we now need to create this last time property for use inside here. Now, obviously we want to store it outside of the method because we're going to keep referring to it, and we therefore don't want to create it each time. So I'm going to go to my header here, and I'm going to add a new property at the end. And again, this is going to be a CF time interval, and this is going to be called last time. Okay, so if I flick back now, and that should do it, we'll save that. Now if we do a build now, we can just make sure that we are okay, we're not actually, or haven't introduced any bugs, and everything builds alright. So we can actually see that we've got a bug there because I went and put tile rather than time. So we'll do that again, and we built it this time okay. So that means that we've now got a very simple calculation that gives us a delta value, and that delta value is the difference between when this game loop last ran and the time now. And we're going to use that to make sure that our animations and our timings are always very, very smooth. So the next thing we need to do is we need to have a method that is going to update the logic in our game. So I'm going to create another method here called update scene. And this method is going to accept a float, and the float is going to be the delta value, because obviously we're going to use this delta value in all of the calculations we do around timing. Now for the moment we're not doing anything in here, but we'll just put a comment saying update game logic, and then we'll close that off. The last thing is this draw view. Now we could just leave draw view as it is, but because we've got update scene, I'd rather actually rename this to be something like render scene. So it does make sense to me later on when I come back to it and I have a look at what's going on. So if we highlight this, I'm then going to use the refactor option in Xcode to rename draw view, and I'm going to call it render scene instead. Okay, so if I preview that, I can see that I've got a couple of entries here, a couple of changes that are going to be made in here, which are fine. This here is telling me that draw view is inside that configuration for the timer, and it's not going to change that itself. I'm going to have to go and change that for it. So by doing that, I need to remember to do this, otherwise it won't work. But I'm going to apply those changes, which makes the name change, and I'm going to just move down to that start animation scene. And we can see here that draw view is still in there, so we want to change that to say render scene. Okay, so that's all we need to do there. So we now have our game loop, which is going to be called, and in fact I've made a mistake there, you may have just spotted it. We actually don't want it to be render scene. We want to now change this to say main game loop. Okay, because we want to call the main game loop every time the timer hits rather than the render scene. So going back up, so we can now say we want the main game loop to be run 60 times a second every time the timer hits, and that's going to ask update scene to run, and it's also going to ask render scene to run as well. So we need to add, once we've calculated the delta there, the calls to those two methods. But before we do that, I just want to add these two method signatures into my project. Now these are purely internal methods to this particular class. They're not going to be accessed from outside this class. So if we have a look at the top of the template, we can see that there is actually a private interface that has been created as part of the template. And so in here, I could actually put put my signatures, so I can actually define them without exposing them to anybody outside. So I'm going to have update scene, which took a float and it was called delta, and I then have render scene, which doesn't take anything. So just to keep things consistent, we'll put that in there. So going back down to our main game loop, in here now what we can do is we can say self, because it's actually the current class where these methods exist, and I'm going to say I want to update scene, and it's going to be delta, and it's going to be self again, and I want to render the scene. So there we have it, very, very straightforward. Main game loop gets called, we work out the timings, we pass the delta into the update scene method, which updates the logic of our entities. We then render the scene, which draws our entities. So this is pretty straightforward stuff, but is setting us up to have a great deal of flexibility and an ease of sort of maintenance, I suppose, as well, to make sure that we can keep the updating of our game separate from the rendering of our game. So we'll just do a quick build on that and see if we get any errors, which luckily we don't. So that's actually working. So if we actually try to run this now, we should just get a blank screen. So let's give that a try. And there we go, we just have a blank screen. Not very exciting. One thing we could do though is if we stop that and go back to our source code, we could actually say, well, let's see if this is working. We want to make sure everything's being called. So what we'll do is we'll add a call into the rendering method, and the call is going to clear the screen for us. Okay, so what we'll do is in here where we have draw game scene, obviously every time we draw a scene we want to make sure that the last scene is erased, otherwise you'll just get, you know, the scenes blurring on top of each other. So there's a GL command for that, and it's called GL clear. Okay, and GL clear allows us to clear the screen using some different masks. Let me just put that in there like that. So there's GL clear, just up here, and you'll see it takes a bit filled mask. Now these are defined for you within OpenGL as constants, so you can just pick them up. And what we're going to do is we're going to have one that's called GL, oops, got a bracket there, GL color buffer bit. Okay, now what that is, that's really saying I want to clear the color buffer, which is where your image is being stored. Okay, the actual image data is being stored. I want to clear it. Now, when you do clear it, which is erasing the screen in effect, what you are doing is you're also using the GL clear color to clear it in a particular color. So now we're saying clear the screen each time that this render scene is run. If we go back up to our definition up here, we can see that we've defined a clear color, but it's black. But if I change the green to full intensity and we run our project again, this time we can see that the actual screen is being cleared to green. So we're just proving really that the actual render method is being run and we're actually clearing the screen, but this is a bit more obvious because it's being cleared to green. So we'll stop that and we'll put that back to black because we want to actually do it to black. And what we now need to do is we need to add in a couple of methods which are inside the crash landing example, because they are going to then allow us to start to draw something to the screen which is going to basically make this a little more exciting than it is at the moment. So now we need to add the classes that are included in the crash landing, and to do that what I'll do is I'm going to create a separate group inside my project where I can keep them away from the other code that I'm actually adding. So if I do new group on here, and I'm going to call this OpenGL ES support, and this is the name that they're actually using in the crash landing examples as well. Once I've done this, I now need to go and actually bring in those two, or the method, it's one method, two files, the header and the .m file, and bring them into my project. So if I go add and I ask for an existing file, I can see here it takes me into where the tutorial is that we're working on, and if I open up crash landing and look inside classes, these are the two files that we're after. So one called texture2dh and one called texture2dm. So if I add those, and I will tick copy because I want them to be copied into my project, so I'm going to change them later. We're going to extend those classes later on to give us some extra functionality we'll need when we're working with things like sprite sheets and working and thinking around things like animation. So I'll add that, and we will then see that we've got the two files that we need for texture2d included. Now at this point, if I actually build our project, we'll see that we get about 18 errors. And the reason for that is that we need to use a framework in here. So if you were to look inside here, and even if you were to look inside the error messages actually, which we can do, you'll see that the error messages that are coming up are around CG, which is core graphics. So that class is obviously making use of core graphics, and what we haven't got is the core graphic framework imported into our project. So if I right click on frameworks, I can then say add existing framework. Okay, and I can then add the existing framework that I want, which for me would be core graphics. Now, if you want to know where this all is, I'll just drop this down here. So I'm going from my root drive, if you like, I'm going to developer, platforms, then I'm going into the OS platform, developer and SDKs. I'm developing on SDK on 2.2. If you're still on 2.1, you'll have a 2.1 directory. If you're on 2.2.1, then you could use that as well. But within there, there's system and then library, which is where I am now. And in there, you'll see frameworks, under which are all of the frameworks that you can use for that particular SDK. So core graphics is the one that I'm after, so I'm going to add that to my project. Okay, and I can see that it's added there, and I'll just do another build, and we can see that the build has succeeded. So we've got rid of those referencing errors that we had before. So now we actually need to start to make use of that, and it's pretty straightforward to use that class, and it's very useful as well. One of the things that you'll find out, as I have going through this, is that textures, which we can use to basically put an image into a geometric shape like a square or a triangle or whatever, those textures have to be something called power of 2, and it means they have to be equal sized. So they have to be 128 by 128 pixels or 512 by 512. You can't have 200 by 100. It doesn't like it, because a texture is actually, when you bind a texture, is actually loaded into video memory to make things nice and fast. It has to have that unique size. Now, normally if you have an image, because we're going to have like a ship, and our ship is going to be a rectangle shape rather than an exact square, so that could be a bit awkward. Now, rather than having to write the code ourselves, we can use this nice little class that Apple have given us, and it does all this work for us. So this takes an image of any dimensions and makes sure that the texture that it creates is a power of 2 texture, so that OpenGL is happy and we don't have to worry about that ourselves. So very, very useful thing to have there. So what we're going to do is we're going to add to the code. So this is inside our init with coder again, underneath the code for initializing OpenGL. And in here, we're going to basically init our images. Okay, so we're going to have a player ship image first of all. So I'm going to flick back into my .header file, which I use Alt Command and up arrow for that to make it nice and quick. And first of all, I need to make sure that I import the texture2d class, which we need to do there. And then I'm going to create a texture2d type, and it's going to be a pointer, and I'm going to call it player ship. Okay, save that and go back into our .m file. So what I can do in here now is I can say player ship equals, and we need to allocate memory for this particular object. So I'm going to say it's texture2, and we need to allocate memory, and then it has a method called init with image, okay, which is a really useful one, and all we have to do is pass it a UI image. So again, I'm going to do square brackets, UI image, and I'm going to go with image named on this, and the actual graphic I'm going to be using is called player.png. It could be whatever the graphic is that you want to use, and then I'm going to close that off. Now, before I forget, because I'm actually allocating memory here, and I'm not going to be doing anything with it until the program ends, just to sort of make sure we're using good best practice, I'm going to go down here and I'm just going to make sure that I actually release player ship when it's no longer needed, okay, just so we don't leak memory. Okay, so I've gone and actually now defined my player ship, and it's of an object called player.png. Bit of a problem here in that I don't actually have that file inside my project to use, and that's where it's going to be looked for. So I'm going to sort that out. I shall create a new group, and I'm going to call this images, and in here I'm going to import an existing file I have, and this is just going to be a file I've got in my graphics directory called player.png. So I'm going to add that into my project, and I want to make a copy of it, and there we have it. And if we have a click on that, there's the ship. So that's the ship that within hopefully just a few minutes we will have drawn in the middle of our iPhone screen, and it will form the basis of our project going forward, and it will also signify the end of this particular tutorial. So going back into our code, I've defined the ship just here, but now I need to actually get it on the screen. So again, that's a relatively straightforward thing to do. So we go down to our render scene here, and we want to, after we've cleared the screen, draw it to the screen. So player ship is the object I'm playing with, and it has a nice method in it called draw at point, which is a core graphics point, an X and a Y coordinate. So we can use CG point make, okay, and I'm going to say I want it in the middle of the screen. So I'm going to have 160 across. And these are floating point numbers, and it's handy being able to use floating point numbers like this because you want to be able to have fractions of a pixel. Not that it can display fractions of a pixel, but when you're moving things, you don't want to have to move them a whole integer point at a time, because that is going to sort of reduce your ability and flexibility to have different speeds of different items. So obviously floats are used a lot throughout the work that we're going to be doing. And I'm going to have it at 240 in the Y, so in the middle of the screen. So we'll close that off there. So I'm going to build this now just to make sure I don't get any errors, and we don't get any errors. And we should now be in a position where we can actually run this project and see what we get. And there we go. There's our little ship in the middle of the screen. Not moving yet, but it is there and it is being displayed using OpenGL. So that brings us to the end of this tutorial. I hope you found it useful and interesting. As I say, I'm hoping that my tutorial style will improve with time. But please post any questions if you have them. And as soon as possible, I'll be following on with tutorial number 2, where we'll be introducing a few more of the basics around, okay, if we've got a ship, how can we move it? And also start looking at things like creating classes to control our enemies, because if we use the object-oriented approach and have a class that controls different entity types, we can start to give them their own logic and their own movement code and things like that. So it's going to be a bit more around the actual project itself and the format we need to take, how we're going to structure our program, but also a little bit about getting that guy moving. So as we tilt the iPhone, we actually see that the ship moves. So join me next time for that, and I hope you enjoyed this tutorial. Thanks very much.